Today we are going to be exploring Chapter 9, Lesson 3, which is on compound events. The essential question for this chapter, as we previously have learned, is how can you predict the outcome of future events? Specifically, what we'll be learning today is to find a sample space and to find probability. Our vocabulary for this lesson is sample space, tree diagram, and compound event. A sample space is a list of all possible outcomes for an event. A tree diagram is where you list all of the options by drawing it out in a diagram. So it would be, for example, if you had option A, and then you would go down to 3, so then you'd have B, 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 and so forth for all of your options. A compound event is an event that consists of two or more simple events, similar to what we saw in Lesson 1. For example, when you're looking at a menu, you want an appetizer, dinner, and a dessert, but there are multiple options of each one. We would be finding how many different combinations you could possibly order. Example 1, the 3 students chosen to represent Mr. Baldrick's class in a school assembly are shown. All 3 of them need to sit in a row on stage. Use a list to find the sample space for the different ways they can sit in a row. So now to make it easier, I'm just going to use A for Adrian, C for Carlos, and G for Greg. So we could start by making a list. So one example would be that Adrian goes first, then Carlos, then Greg. Then we could do Adrian, Greg, then Carlos. Then we could do Carlos, Adrian, Greg. Carlos, Greg, Adrian. And then Greg first with Adrian, Carlos, and Greg, Carlos, Adrian. So we can see that the sample space consists of 6 outcomes. Example 2. A car can be purchased in blue, silver, red, or purple. It also comes as a convertible or a hardtop. Use a table or a tree diagram to find the sample space for the different styles in which the car can be purchased. So now I made a table, so we have to use a table or a tree diagram. I made a table and I separated it into color and the top. So we know that there are 4 color options but only 2 top options. So I wrote each color twice and the top once for each color. And as you can see through this, we can notice that there are 8 possible outcomes. So now this is an example of a tree diagram. And I did color first because that's our first option. And then you can see that there are 4 colors and then there are 2 different top versions for each. So you just do 2 lines because of the 2 options, and then you can see that then this equals our sample space. And I just abbreviated so I didn't have to write out blue convertible, blue hardtop. So you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, which is exactly what we found with our table. Now for this one, you could have done either one, but I wanted to show you both so then you were aware of both options. And for this, if the question would have asked, what's the probability of one of the options? Well, for example, if they would have asked, what is the probability of getting a blue convertible? Okay, that would be 1, which is our favorable outcome, out of the total amount of outcomes, which is 8. So it would be 1/8. Question 3. Suppose you toss a quarter, a dime, and a nickel. Find the sample space, so you can either use a table or a tree diagram, and then find what the probability of getting 3 tails is. I would like you to pause the podcast and try this one on your own. So now I made a tree diagram, and I first put in quarters, then I did 2 lines for the next 2 options, which are either heads or tails for the dime, and then I continued and did that for the nickel. Now I found the sample space, and I just abbreviated each one by H and T. So we have 1, 2, 3, 4, 5, 6, 7, 8 total outcomes in our sample space. So the probability of getting 3 tails in a row, well, I noticed this is the first one, second, third, and we can see it's 3 tails in a row right there. So that's just 1 out of the total of 8. So the probability of getting 3 tails is 1 out of 8. And the last question. To win a carnival prize, you need to choose one of 3 doors labeled 1 through 3. Then you need to choose a red, yellow, or blue box behind each door. What is the probability that the prize is in the blue or yellow box behind door 2? Now, we can see through here that the table shows that there are 9 total outcomes, whereas 2 of them, as they're highlighted here, are the favorable outcomes. They wanted you to, what's the probability that the prize is in the blue or yellow box behind door 2? So door 2 is right here, but only the blue or yellow box, not the red one. So now we know it's 2 out of the total of 9. So we know that the probability that the prize is in a blue or yellow box behind door 2 is 2 out of 9. So make sure that you are writing any questions if you have any, and bring them to class tomorrow, and have a great night or day.